Hey guys, we're going to be starting on page 6, number 16. Let's do a review of what we went over today with the imaginary and complex numbers. So page 6, number 16. This is a Regents problem. And like I said, this is a common type of problem. They love to give you guys something like this as usually a 2-point problem. So given I is the imaginary unit, simplify this as a polynomial in standard form. So standard form, we have to know what that means, whether it's real or imaginary or complex. So let's see what our answer comes out to, and then we'll revisit that. The first thing that we're going to need to do here, this squared tells us to rewrite this or expand this. So 5xi cubed minus 4i. And if we're squaring it, that means we're multiplying it by itself. Okay, and now we have a binomial times a binomial, and we will be double distributing. Okay, 5 times 5 is 25. X times x is x squared. And I cubed times I cubed is I to the 6th. Remember that when we're multiplying, we are adding exponents. Okay, next we have 5xi cubed times negative 4i. So 5 times negative 4, negative 20. X has nothing to multiply with. And I cubed times I to the 1st is I to the 4th. All right, moving on. Now I have negative 4i times 5xi cubed, which is negative 20 xi to the 4th. Again, it's technically the same thing that we just did. And then negative 4i times negative 4i. Well, negative 4 times negative 4 is positive 16. And I times I is I squared. So that's step 1 if we're talking about our lesson from today. Step 1 is to do our multiplication, our distribution. And then step 2 is to simplify any powers of I. Okay, so here I have a few. I have I to the 6th, I to the 4th, I to the 4th, and I squared. Now I'm going to start with the one that we should know. I squared is negative 1. So this term at the end is going to become a negative 16. Because 16 times negative 1 is negative 16. Okay, now you can use your calculator to do the others. I to the 6th, that also should give you negative 1. Okay, so this first term becomes negative 25x squared. I to the 4th, if you don't remember these, you can use your calculator. Okay, and those are just simplified down to 1. So really, they just kind of disappear. So negative 20x, negative 20x. And now we can combine like terms. Do you guys notice anything about what happened to this problem? There are no more i's left over. All of those powers of I simplified to either a 1 or a negative 1. And going back to this standard form, that actually makes sense because if it was going to have an imaginary component, it usually would say in a plus bi form. So that was kind of a hint that it wasn't going to have any i's left over. All right, now our last step is going to be to combine like terms. Oops. So here there's nothing to combine with the negative 25x squared. We end up with negative 40x and nothing to combine with negative 16. And that is it. Okay, so it looks and it starts out more complicated. We have x's, we have i's, but it's really just a combination of skills we already know. We had double distribution, which by now we really need to know how to double distribute. We have combining like terms, which that we definitely should know how to do. The only kind of new thing here is simplifying these powers of I. Okay, so remember that you can use your calculator. Second decimal is I, so if you type in I to the 6th, it will tell you negative 1. It actually will tell you negative 1 plus 0i, but that's because if we're putting it in as an imaginary, they're going to give it back to you as an imaginary, but 0i means there's no imaginary piece, so that's why we're putting negative 1. Okay, same thing when you put in I to the 4th, it will say 1 plus 0i, same thing. 0i means nothing's there. That's where we're getting these ones from. Okay, so with that skill, what I want you guys to do is on page 7, so next page, number 21, is going to be one of your problems on the Schoology assignment. The product of -8 plus 2i and its conjugate is equal to what? Now, conjugate, if we think back to our factoring unit, we talked about conjugate pairs. So conjugate, remember, is its twin, but with a different sign. So think about like Dottie. Dottie had twins. Dot's problems gives us those twins, but one with a plus, one with a minus. So if we are originally working with -8 plus 2i, then its conjugate is -8 minus 2i. And what operation are we going to do with these two things? Well, they want to know the product, so that's multiplication. So this is a double distributing problem. Okay, so those are your hints. I want you guys to do that problem, and you're going to input your answer on the Schoology assignment. So if you want, you could pause this and work on it, or just know you're going to be doing this later. Now, that's our review for today's lesson. Let's go to page 8 and start our new lesson. Now, I kind of told you guys today what was going to be coming next. It was solving quadratics. So we are going back to our quadratic formula. I'm going to model 2 problems for you guys. There are a few different methods for solving quadratics. Let's go to page 9 because I want to jump right into the quadratic formula piece. Using the quadratic formula, which we've already done, the only thing that's going to be different now is that our radical piece is going to end up having a negative underneath here. So the only thing that's different is this last piece where we're going to be simplifying. When we simplify the radical, it's not just going to be breaking it up into the perfect square factors. We also are going to have to simplify that I out of it. But here's the quadratic formula. We do still always need to make sure it's in standard form first, meaning set equal to 0, highest exponent first, then our x's, then our constant. Okay, substitute them in. Remember, every time we're substituting, everything should get parentheses, and then simplify. So I actually want to look at number 3 with you guys. Okay, and you know what? Let me open up my calculator so I have it. Okay, now at number 3, it said that the first step is get it into standard form and get it set equal to 0. Well, right now it's not equal to 0, so I need to subtract 1 on both sides. Okay, that leaves me with -x squared plus 2x minus 1 equals 0. Now, is that in standard form? Yes. Okay, we have our x squared, then our x, then our constant. So this leaves me with a is -1, b is 2, and c is -1. All right, so now we're going to substitute this into the quadratic formula, which is x equals -b. So I'm going to start out with a -2 plus and minus, and now our big square root. B squared, so 2 squared, minus 4 times a, which is -1, times c, which is -1. All over 2 times a, which is -1. Okay, so all I just did is substitute these a, b, and c values into the quadratic formula, which you guys have right at the top of the page. Okay, now just like our process that we did last unit when we did not have imaginary numbers yet, we're following the same steps. Now we need to simplify this discriminant. Remember that piece under the radical is called the discriminant? So I'm typing this in my calculator. Remember, we are not putting in the square root. I just want to know like what actually lives underneath that square root for right now. So I'm typing this in and I get a 0. Oh, so maybe this wasn't the best problem to do with you guys, but it's a good way to show you a different type. So I get -2 plus or minus the square root of 0 over 2 times -1 is -2. All right, guys. Well, what is the square root of 0? It's just 0. So what I really end up with in my numerator is negative 2 plus and minus 0. So I'm not even going to put that. Negative 2 over negative 2, which actually only gives me one answer, right? There's nothing to add and subtract. So this is an example of a one